Meteorites are among the oldest physical objects a human can ever touch, fragments of a time long before Earth had oceans, continents, or even a solid surface. They are not just rocks, they are relics of cosmic history, traveling across unimaginable distances to deliver messages from the birth of our solar system. Every meteorite that reaches Earth carries within it a story that began over 4.5 billion years ago, when a vast cloud of gas and dust collapsed under gravity to form the Sun and the planets. In that early chaos, countless small particles collided, merged, and shattered again, forming larger bodies known as planetesimals. Some of these would eventually grow into planets, while others remained as debris scattered throughout the solar system. These remnants still exist today as asteroids, comets, and smaller fragments known as meteoroids. Occasionally, one of these meteoroids is pulled toward Earth, beginning a dramatic journey that will end in fire and light. As a meteoroid enters Earth's atmosphere, it does so at incredible speeds, often tens of kilometers per second. At such velocities, the air in front of the object cannot move out of the way quickly enough and becomes compressed, heating up to extreme temperatures. This intense heat causes the outer layers of the meteoroid to vaporize in a process called ablation, creating a brilliant streak of light across the sky known as a meteor. Contrary to popular belief, this glowing trail is not the object burning like a flame, but the result of ionized gases emitting light under extreme conditions. If any part of the meteoroid survives this violent passage and reaches the surface, it becomes a meteorite. Meteorites come in a remarkable variety of types, each offering clues about different parts of the solar system. The most common are stony meteorites, composed primarily of silicate minerals. Within this group, chondrites are especially important because they contain tiny spherical inclusions called chondrules, which formed as molten droplets in the early solar nebula. These structures have remained largely unchanged for billions of years, making chondrites some of the most primitive material available for scientific study. By analyzing them, scientists can reconstruct the conditions that existed when the planets were first forming. Another major category is iron meteorites, which are composed mainly of iron and nickel. These are believed to originate from the cores of ancient asteroids that were once large enough to undergo differentiation, separating into layers with dense metals sinking to the center. When these bodies were later shattered by collisions, fragments of their metallic cores were ejected into space, eventually finding their way to Earth. The crystalline patterns, known as Widmanstätten structures, reveal slow cooling over millions of years, something that could only occur inside large parent bodies. Stony iron meteorites represent a rare and fascinating combination of both rock and metal. They are thought to form at the boundary between the core and mantle of differentiated asteroids, offering a unique glimpse into planetary interiors. Some of these meteorites, such as pallasites, contain beautiful transparent crystals of olivine embedded in a metallic matrix, creating structures that are as scientifically valuable as they are visually stunning. The journey of a meteorite does not end when it reaches Earth. In fact, that is when its story becomes most accessible to us. Scientists carefully study meteorites using advanced techniques, including isotope analysis, electron microscopy, and spectroscopy, to determine their composition, age, and origin. Some meteorites have been traced back to specific regions of the asteroid belt between Mars and Jupiter, while others have been identified as fragments of the Moon or even Mars itself. These Martian meteorites are particularly valuable because they provide direct samples of another planet without the need for a sample return mission. One of the most intriguing discoveries within certain meteorites is the presence of organic molecules, including amino acids. These are the building blocks of life as we know it, and their existence in meteorites has led scientists to consider the possibility that the ingredients for life may have been delivered to early Earth from space. While this does not mean that life itself came from meteorites, it suggests that they could have played a crucial role in setting the stage for its emergence. Meteorite impacts have also had profound effects on Earth's history. While most meteorites are small and harmless, large impacts can release enormous amounts of energy. The most famous example is the impact that created the Chicxulub crater approximately 66 million years ago, an event widely believed to have caused the extinction of the dinosaurs. The collision would have generated shockwaves, global wildfires, and a massive cloud of dust and debris that blocked sunlight, leading to a dramatic drop in temperatures and the collapse of ecosystems. Even smaller impacts can be significant on a local scale. Craters formed by meteorites can be found all over the world, from the Barringer crater in Arizona to ancient, eroded structures that are only recognizable through geological analysis. These impact sites provide valuable information about the frequency and scale of collisions throughout Earth's history, helping scientists assess the potential risks posed by future impacts. In modern times, the study of meteorites is closely linked to planetary defense. By understanding the composition and structure of these objects, scientists can better predict how they would behave if they were on a collision course with Earth. Some may break apart in the atmosphere, while others could reach the surface and cause significant damage. This knowledge is essential for developing strategies to detect, track, and potentially deflect hazardous objects before they pose a serious threat. Despite advances in technology, many meteorites still go unnoticed when they fall to Earth. The majority land in oceans or remote areas, far from human observation. However, certain regions, such as Antarctica and desert environments, are particularly well suited for meteorite recovery. In Antarctica, the contrast between dark meteorites and the bright ice makes them easier to spot, and the movement of glaciers can concentrate them in specific areas. These natural processes have turned the continent into one of the richest sources of meteorites on the planet. Meteorites have fascinated humans for thousands of years. In ancient cultures, they were often regarded as sacred objects, believed to be gifts or omens from the heavens. Some early civilizations used meteoritic iron to create tools and weapons long before the development of metallurgy. These artifacts stand as a testament to the profound impact that meteorites have had not only on science, but also on human culture and imagination. Today, meteorites continue to inspire curiosity and wonder. They connect us to the broader universe in a tangible way, reminding us that the Earth is not isolated, but part of a vast and dynamic cosmic system. The atoms within these space rocks were forged in the hearts of stars, scattered across space by supernova explosions, and eventually incorporated into the solar system. In this sense, meteorites are more than just objects. They are pieces of a much larger story, one that includes the origins of planets, the potential for life, and the ongoing evolution of the universe. As we look to the future, meteorites will remain an essential tool for understanding our place in the cosmos. Each new discovery has the potential to reveal something unexpected, to challenge our assumptions, and to deepen our knowledge of the universe. Whether they arrive as tiny grains of cosmic dust or massive objects capable of reshaping entire ecosystems, meteorites remind us of the dynamic and sometimes unpredictable nature of the universe we inhabit. And so, the next time you see a streak of light crossing the night sky, take a moment to consider what you are witnessing. It is not just a fleeting flash, but the final chapter of a journey that began billions of years ago, a journey through the vast emptiness of space, ending in a brief moment of brilliance that connects our world to the deepest origins of the cosmos.